We were talking about elements, and that brings us to the periodic table. So Dmitry Mendeleev was a Russian scientist who's often given credit for the development of the modern periodic table. He proposed what's known as the periodic law, that when elements are arranged in order of increasing relative mass, certain sets of properties recur periodically. So if we look at this abbreviated section of the periodic table, we've taken the first 3 rows plus a couple, and we've gotten rid of that big gap in the middle where it says periodic table of the elements, and we've squeezed these together so they go 3, 4, 5, 6, 7, 8, 9, 10. What Mendeleev observed is that if you order the elements in this way, that we see recurring properties. So lithium, sodium, and potassium have a number of properties that are very similar to each other. Beryllium, magnesium, and calcium have similar properties. Fluorine and chlorine are similar in many ways. Helium, neon, and argon are similar. And that's what we mean by these recurring properties. It's a little bit like a piano keyboard, where you have octaves. There's middle C and there's the C above middle C. Those two notes do not make exactly the same sound, but one is just an octave higher, essentially the same note. Okay, so it's a little bit like that. So if you just put them in a line, you see, okay, there's helium. It's a very unreactive gas. And then you skip 1, 2, 3, 4, 5, 6, 7, 8, and there's another unreactive gas, neon. 1, 2, 3, 4, 5, 6, 7, 8, and here's another unreactive gas. And that was a big discovery. Remember, people were discovering elements, and in the beginning of chemistry, there was just a bunch of information, and then we tried to put it together in a more cohesive way to help us make sense of it. So here is an example of the modern periodic table, and there is so much information hiding in this periodic table. There are some things that you're going to need to know. Let's look first at this line here. Come on, pointer. There's the pointer. You see this dark stair-step line? Periodic tables on the wall have blue tape accenting that line. That is the division between the metals and the nonmetals. The nonmetal elements are shown in green on this periodic table. The metals are shown in this sort of beige color. And then along that stair-step line are some elements that are known as metalloids or semi-metals. They have properties that are in between. They're not really a metal, but they're not really a nonmetal either. And so just by location on the periodic table, we can identify if a substance is a metal or a nonmetal. If you have a hard time remembering which side is the nonmetals, well, think of an element you have some experience with. Perhaps oxygen. Is oxygen a metal? No. Well, then these guys must be the nonmetals. Or think about iron. Is iron a metal? Yeah. So the ones on that side are metals. What about hydrogen over here? He's green. What's he doing over here? Hydrogen is like the baby brother of the element family. You know, the youngest kid in a big family gets away with breaking all kinds of rules, right? Because, oh, they're so cute. Actually, it's because mom and dad are really tired and we just don't care anymore. We have one of those. His name is Andrew. So we will see over and over again that hydrogen breaks all the rules. So don't be shocked that hydrogen is hanging out over here. We have other numbers on here. We learned about these whole numbers. Those are the atomic numbers. That tells us the number of protons that each atom of that element has in its nucleus. On the left, we have rows that are numbered. Those are called periods. So this is period 1, period 2, period 3, etc. And then we have the columns are numbered as well. Now, there's 2 different sets of numbering on the columns. The 1A, 2A, 3B type numbering is what we currently use in the United States. IUPAC has just numbered them from 1 to 18 across the top. I prefer the first one with the numbers and letters. And the periodic tables on the wall, the periodic table that you'll be given for the exam, will have both numbering systems. Okay. So let's talk about the metals and the nonmetals. I'm going to go over some of this stuff really quickly because it's all in your textbook and there's not that much to explain. Metals have similar properties. The biggest things are they're good conductors of heat and electricity. That's why we use them for pans and for wire, etc. They can be pounded into sheets, drawn into wires. They're often shiny. And this is an important one. They tend to lose electrons when they undergo chemical changes, and there are some examples. The nonmetals are on the other side of that line. Their properties are not as predictable as the metals. Some are solids at room temperature, some are gases. They are generally poor conductors of heat and electricity, but not always. They tend to gain electrons. So the metals lose electrons and the nonmetals gain electrons. And there are some examples listed. The metalloids are along that zigzag line. They have mixed properties. They are also called semiconductors, and you've probably heard that word, right? Semiconductors are really big in the Silicon Valley, right? Silicon is a semiconductor, and that's an essential part of making computer chips. They have intermediate electrical conductivity. They're not as conductive as metals, but they're not as unconductive as nonmetals. And their conductivity can be controlled, and so that makes them very useful in computer chips. So, using our newfound information, classify each element as a metal, nonmetal, or metalloid. S is sulfur. What is it? Nonmetal. I'm going to call that N, nonmetal. How about chlorine? Nonmetal. How about Ti? Ti is titanium, and titanium is a metal. Notice you can do these, you can answer these questions even if you don't know what the element symbols are. Sb, anybody know what element that is? Antimony. That's a metalloid. Oh, I guess metal and metalloid. I'll have to write out the word here. That's a metalloid and that's a metal. Any questions? My question is, why can't I remember to get a new stylus? So we can also divide up the periodic table into main group elements and transition elements. So here in the yellow, the columns that stick up higher, these first two and the last six, the elements in those sections are called main group elements. Their properties are more predictable than other elements in the periodic table. In between those two sections, we have the transition elements. They transition from one section here to another, and their properties are not as predictable. Some of the columns have names. We refer to the columns in the periodic table as families or groups. So group 1, these are called the alkali metals. And again, hydrogen is sitting over there, although in the sense of alkali metals, hydrogen doesn't really belong there because it's not an alkali metal. But the other group 1 elements are alkali metals. Group 2A, these are called the alkaline earth metals. You know, those names are a little bit similar, but you got to keep them straight. Then over here, we've got some groups that just never got really a name. Group 7A, these are called the halogens. You've heard of halogen headlights? Halogen headlights are going to have one or more of these elements in there. And then group 8A, these are the noble gases. Again, here's the transition elements. These guys at the bottom, did you ever wonder why there's those two rows stuck at the bottom? Well, on this periodic table, we see a little gap here and an arrow. Look what happens with the numbers. 55, 56, 57, 72. Wait a minute. We skipped some. It should go 57, 58, 59, go all the way through here to 71, and then jump back here. We really should take a scissors and cut it right there and stick this up in the middle. That makes the periodic table really long and skinny. It doesn't fit on a piece of paper very well. It doesn't fit on a screen very well. And these guys down here are uncommon elements that we don't use very much. So we kind of just pulled them out and stuck them at the bottom. They're still there, but they're just stuck at the bottom. You don't need to know these, but these are called the lanthanides because they come after lanthanum, and these are called the actinides because they come after actinium. And then your book goes through just some general characteristics of these different named groups or families. The alkali metals are really reactive. I mean, like crazy reactive. This is an example of what happens when you stick sodium in water. It reacts so vigorously and produces hydrogen gas and so much heat that the hydrogen gas just ignites. The alkaline earth metals are fairly reactive, but not as reactive. If you take pure calcium metal and stick it in water, it will just bubble and react with the water. Magnesium will burn. Most metals don't burn, right? You know, we make things out of metal, like pots and pans. It would be bad if those burst into flames. There's a reason we don't make frying pans out of paper, right? Because they would start on fire. So we don't think of metals as being flammable, and yet some metals are very flammable. Magnesium is one of them. The halogens are very reactive nonmetals. Fluorine and chlorine are gases at room temperature. Bromine's a liquid, and iodine and astatine are solids. On the periodic tables on the wall, the colors of the element symbols tell you what the state is at room temperature. So the ones with the red letters, those are gases at room temperature. The ones with black letters are solids at room temperature. And there's only two with blue. Bromine and mercury are the only two elements that are liquids at room temperature. Then we have the noble gases. These are chemically inert gases. Some of them, like helium, have no known compounds. No one has been able to make a compound out of helium gas. And that's what makes it, really nice for balloons. It's not going to explode. You're probably familiar with neon signs. An orange neon sign like that has neon gas in it. When you pass electric current and excite the neon gas, it glows that very, very distinctive orange color. Okay, so you need to know those named families and be able to identify which family these belong to. So Li is lithium. What family does it belong to? The alkali metals, because it's in group 1A. How about boron? Well, it's not in one of those named groups, is it? It's not a halogen, it's not an alkaline earth metal. Well, we had other parts of the periodic table, main groups and transition elements. That would be a main group element. So it's in the main group, but those guys aren't special enough to get their own name. How about I? That's a halogen. Iodine. And Ar. That's argon. It's a noble gas. Any questions?